Everyone, I'm Rosemary Talipan Uba from BSEE 1A. So, Lecture 4 about conservation of energy, momentum, impulse, and collation. So, problem set number 1. Check your understanding 8.7 page 374. So, question is, how high above the bottom of its arc is the particle in the simple pendulum above, when its speed is 0.81 meter per second? So, given below is velocity, which equals to 0.81 meter per second. And let's find the height, solution. Kinetic energy plus potential energy, which equals to Kf plus Uf. So that 0 plus mgh, so ato ang kinetic energy is 0. And our potential energy is mgh, which equals to 1/2 mass velocity squared plus 0. So at mgh over mg. So ato i-cancelled out ang mass gravity para makita na to ang height, which equals to 1/2 mass velocity. By substituting the formula based on the given problem, from 0 is equal to change of kinetic energy plus potential energy, we arrive this formula. So, kani, mana na siya. Then, h equals 1/2 velocity squared over gravity. So, h, which equals to 1/2 0.81 meter per second squared. So, kaning 0.81 meter per second squared, mauna na siya ang given sa ato ang velocity. So, over 9.81 meter per second squared. And then, mauna siya to ang gravity, ang 9.81 meter per second squared, which equals to 0.32805 meter squared squared. So, mauna to ang final kinetic energy and potential energy over the gravity, which is our gravity is 9.81 meter per second. So, the final answer sa height is 0.33 meter. Problem set number 2. Example 8.8 page 375. So, question. Air resistance on the following objects. A helicopter is hovering at an altitude of 1 kilometer when a panel from its invertible breaks loose and plummets. To the round figure 8.9, the mass of the panel is 15 kg and it hits the ground with a speed of 45 meter per second. How much mechanical energy was dissipated by air resistance during the panel's descent? So, the given below is mass, which equals to 15 kg. So, ato ang mass is 15 kg. And for our velocity, which equals to 45 meter per second. And yi, or our height, is 1 kilometer. So, finding the energy dissipated. So, given problem, these are given value. And the problem, we only investigated by the one body. And gravitational force or resistance is naani sila dapat ang tulo. Katong gravitational force, conservative force, and air resistance. And then, however, the conservation force of air resistance does negative force of taken panels. So, our energy dissipated, so katong formula atong gamiton sa energy dissipated. So, amo datong pangitaon. So, in this problem, we use the equation 8.12 and pangitaon na to ang energy dissipated. So, that equals to the absolute value of the non-conservative work equals to the absolute value of the change in kinetic energy plus potential energy. So, mani siya, 1/2 mass velocity squared minus 0 plus 0 minus mgh, or mass gravity height. And then, 1/2 times 15 kilogram times 45 meter per second squared minus 0 plus 0 minus 15 kilogram, 9.81 meter per second squared times 1,000 meter. So, kani di ay, ang mass di ay is 15 kilogram. So, mano siya? 15 kilogram. And then, ang velocity pod is 45 meter per second squared. And then, apong gravity is 9.81 meter per second squared. Tapos, ang height or height nato is 1,000 meter. So, nganong na 1,000 meter man na by converted the 1 kilometer and 2 meters. So, that by simplifying the absolute value, so 15,187.5 plus negative 147,000. So, ato pa yun siya i-simplify. I-simplify pa yun nato the absolute value. So, negative 131,812.5 joules. So that simplifying using the scientific rotation or notation, we arrived the answer is 130 times 10 to the raised power of 3. Therefore, the energy dissipated is 130 kilojoules. Let's move on to the problem set number 3. Example 9.1, page 400 to 403. The Arizona meteor crater. Approximately 50,000 years ago, a large or a radius of 25 meter iron and nickel meteorite collided with Earth at an estimated speed of 1.28 times 10 to the 4th power meter per second in what is now the northern Arizona desert in the United States. The impact produced a crater that is still visible today. Or figure 9.7, it is approximately 1,200 meter, 3/4 of a mile. In diameter, 170 meter deep and are a rim that rises 45 meter above the surrounding desert plain. Iron nickel meteorites typically have a density of P which equals to 7970 kilogram per meter to the raised power of 3. Use impulse considerations to estimate the average force and the maximum force that the meteor applied to Earth during the impact. So, given below the initial velocity. So, ang atong initial velocity or VI which equals to 1.28 times 10 to the 4th power meter per second. So, our meteorite which is 25 meter and our density which equals to 7,970 kilogram per meter to the raised power of 3 raised power. So, find we are going to find the average net of force and maximum force. So, first is, ato ang gamiton first is average force, atong pangitaon rather. So, during the impact and relative to the impulse, average force is equals to meter times change to the velocity over time. So, the mass is equals to intensity, its density, and its volume. So, density of meteors, 7,170 kilogram. So, kilogram over meter per meter cube. So, the volume of matter is equals to P times the quantity of 4/3 pi r cube. So, the average of force is equals to the density times the times the volume times the velocity over time. So, the final velocity minus the initial velocity over time by substituting density. So, 7,970. So, mao ni ato ang density. So, atong R is 25 meter to the raised power of 3 is, mao na siya ato ang R or our meteorite. So, velocity po nato is negative 1.28 times 10 to the raised power of 4th to the 4th power. And then, nganong koan man, nganong na negative ang 1.28 because the meteorite is traveling vertical down prior to the impact, that is initial velocity became always negative. So mahimo na siya positive kuan kay because by simplifying the same sign mana siya. So therefore our average force is positive 3.33 times 10 to the 12th power Newton. So continuation for the problem set number 3. So that let's calculate the maximum force. The impulse is related to the force functions by integral of maximum time and initial time. Force function dt maximum or dt equals to maximum force raised to the negative plus squared squared I, and time is parameter represents to the rapidly force the 0 to the raised power of 0 squared rather dt maximum time minus 0 second. So that ato ang mauna niya itong final average kanang 0.458 kuan kanang maximum force. So 0.458 maximum force over 0.458 ato na siyang i-crush out, ato na siya i-divide. So makakuantag ko ng answer 3. Ang 3.333 times 10 to the 12th power Newton. So mao na to ang kuan, di ba? Final initial velocity. Our average force rather. Dayon 0.458. So kani atong 0.458 man ni atong maximum force. So ato ang maximum force average is 7.27 times 10 to the 12th power Newton. So mao na siya ato ang final answer sa ato ang maximum force. Problem set number 4. Example 9.3, page 406. Moving the Enterprise Master Solo take out ahead 1/4 impulse. With this command, Captain Kirk of the Starship Enterprise, figure 9.11, start from rest to a final speed of final velocity which equals to 1/4 3.0 times 10 to the raised power of 3 meter per second, assuming maneuver is completed in 60 seconds. What average force did the impulse engines apply to the ship? So given final average final velocity VF, which equals to 1/4 3.0 times 10 to the 8 power meter per second, and our intensity intensity, so 0 meter per second, and our time initial velocity rather. Then our time, which equals to 60 seconds. So mass of Enterprise, which equals to 2 times 10 to the raised power of 9 kilogram. So finding F, force. So force atong pangitaon. So the solution is impulse. We can use the formula momentum theorem. So mani siya mani siya o kani ato ang formula. So impulse is equals to delta P. Delta P is equating those 4 times the change equal mass times change the velocity. Aron kuan by finding or makita na to ang first is atong i-cancelled out ang time. So mani siya atong i-cancelled out ang time. And then by arriving formula, force which equals to m times change the velocity over time, or mass times change the velocity over time. By substituting na pod mass Enterprise velocity which equals to 7.5 times 10 to the 9th power meter per seconds. And then ato apong time is 60 seconds. So the final average ay overtime man is so 2 times 10 to the 9th power kilogram. And then 7.5 times 10 to the raised power of raised power of 9 meter per seconds over 60 seconds. So makakuha na din sa atong final average for sa problem set number 4 is kanang 2.5 times 10 to the raised power of 15 Newton. So mo na siya to ang answer. So that would be all. Thank you and God bless.